Hello everybody. Today we're going to learn how to read the periodic table. We're going to start out with an individual block on the periodic table. This is the block for tin, number 50. So blocks on the periodic table give you several different kinds of information. First of all, you have the element name. That part's pretty easy to figure out. You have the element's symbol. The symbol always begins with a capital letter. If there are two letters, the second letter is always lowercase. It can never be capital. Nothing on the periodic table that's up to date will have three letters. Some of the ones that are a few years behind that were printed a while ago may have three letters down here at the bottom. We can talk more about that later in class. I won't be asking you any questions about those elements for the most part, except for perhaps I'm going to ask you number 118, but we'll come back to that. Okay. The next thing you're going to see on a block on the periodic table is the atomic number. This may be up at the top, it may be down at the bottom, okay, the location isn't standardized. There are two numbers that you'll find in every block on the periodic table. Whichever one is lower in value is going to be the atomic number. It's also always a whole number. The atomic number is important because it tells you the number of protons in an atom. If you change the number of protons, you change the atomic number, and you change which element you're talking about. The atomic number also tells you the total number of electrons in a neutral atom. Unless someone tells you differently, you can assume that all atoms are neutral. The other thing that you're going to see in every block on every periodic table is another number that usually has a decimal point and some numbers after it. It will always be higher in value than the atomic number. This is the atomic mass. The atomic mass is found by adding the number of protons plus the number of neutrons. So that's how you read every block in the periodic table. Now let's discuss how to read the periodic table itself. First of all, the periodic table is divided into 7 horizontal periods. The periods are horizontal. Now, I have some students who say, no, here's number 8 and number 9. No, the periodic table doesn't actually look like that. The periodic table actually looks like this, but that's really long, and it won't fit on a single piece of paper. So in order to make it a little more convenient to print, what we normally do is we cut between 57 and 70, the lanthanides, and also between 89 and 102, the actinides, and we move these down here to the bottom. You've seen maps of the United States that have the 48 lower states all in one place. But then they cut Alaska off and they shove it down near the bottom, somewhere near Texas. And usually they move Hawaii there too. Hawaii and Alaska are not actually in the ocean off of the coast of Mexico. But they have been moved there on the map just to make it easier to see them. The lanthanides and actinides actually belong here. But because that's difficult and inconvenient, we usually cut them out and move them down here. You just need to remember that this is actually in row 6 right here, and this is actually in row 7 right here. So there are 7 periods. They are horizontal. Each period tells you the number of energy levels, or electron shells. So everything in period 3 will have 3 energy levels. Everything in period 6 will have 6 energy levels. Everything in period 2 will have 2 energy levels. It's very logical that way. So if I ask you any element on the periodic table, let's say iridium. It's one of my favorites. Iridium is in period 6, so we know that it has 6 energy levels. Cobalt is in period 4, so we know it has 4 energy levels. That's what the periods tell us. Then we have vertical groups. Each group on the periodic table has the same number of valence electrons. That's the number of electrons in the outermost energy level. Everything in group 1 has 1 valence electron. Everything in group 2 has 2 valence electrons. And this is true for all of what we call the main group elements. The main group elements are everything in this column over here and this big section over here. It does not include these transition metals. Now, on this particular periodic table that I have, the transition metals are printed in pink. There is not a standard color system for periodic tables. Every periodic table can do what they want to as far as color goes. So there will be a key on your periodic table. You need to look at it, and it's going to tell you all of this information, including the atomic number, the chemical symbol, the element name, the atomic, in this particular case it says atomic weight. I use the term atomic mass. They're pretty similar. So the pink transition metals, pink on my chart, different color on yours probably, do not have a pattern to their valence electrons. You cannot guess those by looking at the periodic table. You would have to look it up. I will never make you memorize these. There are 2 transition elements that have a consistent number of valence electrons. I will tell you what those are and have you write it down. All of the others, you won't need to know. But group 1 has 1 valence electron, group 2 has 2 valence electrons. You need to know that. We're going to skip over here to boron's group number 3. That has 3 valence electrons, 4 valence electrons, 5 valence electrons, 6 valence electrons, 7 valence electrons. Okay? The group tells you how many valence electrons they have. The last group, it's just a little bit of a complication. These are the noble gases. They have 8 valence electrons, except for except for helium. Helium only has 2 valence electrons because it only has 2 electrons to begin with. It only has 2 total. So helium has 2 valence electrons. The noble gases have 8 valence electrons. How do you know which ones are the noble gases? Again, there's probably a color code key for your periodic table. So remember, each individual block gives you a symbol and a name. The number that is lower in value is the atomic number. That's equal to the number of protons and electrons. There is a number that is larger in value. It usually has numbers after a decimal. That is the atomic mass. On the periodic table itself, it is divided up into horizontal periods. Each horizontal period tells you the number of energy levels, aka electron shells, that atoms in that period would have. It is divided into vertical groups. Each group tells you the number of valence electrons, the outside electrons. That is not true for the transition metals, but in this class you will not have to know valence electrons for the transition metals. I hope this helps you to understand how to use your periodic table. The biggest piece of advice I can give you, make certain you are reading the key and write down periods are horizontal. They tell you the energy levels or electron shells. Groups are vertical. They tell you the number of valence electrons. And I would recommend you write the number of valence electrons at the top of each group and perhaps write the number of energy levels for each period. But that's up to you. I hope you have a good day.